Hello, we're going to be going over the SBM Trailers Model Cold Train. This is the final presentation for the Engineering Advisory Board. The following group members are John Scotto, myself, Taylor B., Ethan Myers, and Cole Tinsley. Next slide, please. Contents. We're going to be going over the introduction, purpose, and identity of project, project constraints, project associated risks, schedule and timeline, budget and funding. Next slide, please. Here are the team members. John Scotto on the left, Cole Tinsley in the center, Taylor B to the right, and Ethan Myers. Next slide. John Scott Rodriguez and was in charge of investor relations. He's an experienced farmer and assembly engineer. John Scott Rodriguez secured critical project funding by leveraging his extensive agricultural business network, serving as a primary liaison for potential sponsors. He ensured a consistent flow of financial resources to support material acquisition and rapid prototyping. Additionally, his hands-on expertise in mechanical systems contributed directly to the physical assembly and integration of key project components. Next slide, please. Cole Tinsley, lead researcher. Cole led the project's research, focusing on legal and ethical and regulatory compliance. He ensured the trailer met all relevant engineering standards and safety codes. In addition to his research, Cole contributed to fabrication by assisting with drilling, alignment, and assembly, bridging the gap between compliance and construction. Next slide. Taylor B., team manager, fabrication specialist. Taylor B. led the project team with precision, overseeing task, delegation, setting critical deadlines, and tracking progress using tools such as Gantt charts. In addition to his strong leadership and organizational skills, Taylor contributed extensively to hands-on fabrication, utilizing advanced welding techniques to construct and assemble structural components. His dual role as manager and skilled welder ensured the project remained both technically sound and on schedule. Next slide. Ethan Myers, lead CAD designer. Ethan Myers led the technical aspects, developing CAD models, performing load-bearing calculations, and ensuring the design compiled with industry standards. He also created the parts list and led fabrication after the frame was welded together. Next slide.
Hi, my name is Taylor B. I'm going to be going over our project identity and purpose. So first thing is that we initially want to develop a 53-foot trailer. This is because that's what's standard and that's what gets used on farms for transporting hay. The primary objectives for this was to make it self-loading so that farmers could eliminate the use of multiple equipment and be able to kind of consolidate into one single trailer. So our initial focus was to focus on small 60-pound bales. The reason for this is because that's what our primary customer uses. Additionally, this is because it allows us for adaptability into bigger, larger array of bales. And so the design here kind of stressed simplicity, safety, durability, and ease of maintenance. Next slide, please. Moving on to our qualitative and technical constraints. So qualitatively, we had our budget constraints. That was obviously limited because we only had so much money. Our limited timeline, additionally, since we are students, we only have so much time. Team coordination, demonstration quality, and local support. Those were all things that we all had to work around with and kind of modify the project as we went through. Specifically, demonstration quality. Initially, we wanted to bring our trailer on. However, I don't believe that's going to be the case because we're not able to have a trailer in where we're doing our demonstration since it's going to be inside. So that's just not feasible. Our technical constraints consider the things of like the trailer weight, material use, manufacturing limitations, the compliance standards, and substantial system scope / complexity. So going over those, essentially, really the trailer weight was kind of a big thing is that we wanted to keep that as low as possible so that there wasn't unnecessary weight, just because that would add to cost and it would also make it difficult for transportation and mobility. Additionally, we wanted to optimize material to lower costs. Same with manufacturing. We wanted to try to optimize our manufacturing possibilities, compliance and standards. If we can't have our trailer actually be sold and be used on the road, well, then that's no point in making it. And then lastly, our substantial system is that we had a lot of parts initially that we wanted to have on our trailer, and we just realized that the scope was just getting so large. So we just eventually had to kind of tone that down. So moving on to our applied skills that we've learned throughout our engineering, um, really kind of starting out from the top is that we have our statics and structural analysis. This was done through hand calculations that you guys will see later to really ensure that our design does and will fit our job and be safe. And we used our FEA to kind of go through and validate that. We used material science to kind of make sure we had the right materials, make sure we didn't overpick our materials and just over engineer it so it wasn't super expensive. Machine design, again, that's with selection of like the motor, hydraulic lines, stuff like that to kind of make sure that the components we selected were up to snuff for the forces expected to be used. Safety factor and failure analysis. So these were done essentially to make sure that our trailer was actually done in verification, make sure that it was going to hold up to the weight and expected forces in use. And then safety factors, this was done to make sure that the trailer would be able to hold up to excessive use in the field and not be able to break. So moving on, thank you.
Hi, I'm Cole Tinsley, and I'll be going over the stresses and deflection, basically just how we analyze those on each and every component of our project. I'm also going to talk about risks and what we did to solve some of those and to mitigate them. And lastly, I'll be going over some of the codes that were relevant to our project. So this is just a basic outline of how each component was analyzed. Maximum deflection to ensure that nothing is going too far beyond our bounds, maximum bending stress, and alongside a normal stress. These are just the basics of how we analyzed each part and what we needed each part to do. Taylor, can I get the next slide? Right. Risk management, especially our initial design parameters were a little bit beyond what our means were. Cost-wise, weight-wise, moving parts from place to place and having a larger trailer was a little bit beyond what we could do for this project. In complexity, especially in terms of features. We ran into time and delays because we couldn't get a solid prototype design laid out. The solutions to those problems, funding brochures were made by Scotto, and he networked with some people that he knew so that we could get some of those costs handled, and we didn't have to reduce our scale and size too much, but we did have to reduce them pretty significantly from our initial design perspectives. So we ended up with two designs, more or less, one for a full-scaled commercial idea and one for the prototype that we're doing for our project, which should be able to serve as a proof of concept for those later ideas. We ended up coming up with the prototype design collaboratively, what needed to be on there and what didn't, so that we could get it within the scope that we could handle. Next slide, Taylor. Thank you. Okay, for risk management, we also had to take into consideration liability and making sure that everything was safe enough that even just constructing and operating the prototype was within certain bounds of safety. So warning labels, road security, getting it from place to place, DOT codes, making sure it's all within the bounds of what we can do. And for the current concerns, that refers to the prototype problems. Again, travel, making sure everything's secure when we're getting it from place to place, and making sure the project functions safely. Future concerns having to do with a full-scale idea that we haven't fully fleshed out. Full load travel, security and legality, labeling, a lot more to consider for a larger scaled thing that could be commercialized. Next slide, please. Right. Here are just some of the codes that were key in designing our prototype and that are relevant to our project. Max trailer widths in Washington via the Washington Administrative Code, 102 inches across. And max trailer load, this is because our prototype is connected to what was a boat trailer. We're basing it on a class 1 boat trailer is 2,000 pounds maximum on that. So we had to kind of associate that through the GEVWR rating system. Trailer connections and safety systems, the ISO standards, the International Organization for Standardization, has a lot of good resources for this stuff for ensuring that our safety system, design principles, and agriculture machinery are all within the bounds of what we needed to handle. Next slide, please. Right, and these were more specific to some of the systems that we have on our trailer. The hydraulic system that runs our motor to pick up the bales and bring them onto the trailer. We again have to refer to those ISO standards, and for the electrical standards, it's a little more complicated because the UL has to do with the underwriters' laboratories, safety system benchmarks, basically how something is designed, whereas the electrical system application standards can come through the National Electrical Code, which has to do with how we're installing it and how we're using our systems. I think that's it for my portion. Go ahead, Taylor.
Awesome. So thank you. So this is initially our proposed timeline that we're going to be going over. It's a little difficult to see, so it'll be given in our appendix. But what we can see here is that our initial idea happened around August, and we kind of wanted to hope to have our materials ordered kind of in October before the end of the year, start building, and then kind of start to test around early the year, February or so. But you'll kind of see that, unfortunately, it wasn't the case that we were able to maintain. So here, real quick, is a review for fall term. So for fall term, from August to September, we were able to do our concept generation. That was just essentially coming up with the idea. October was the modeling period we had. November, we were able to put together an estimate for the material. Fundraising happened during November and December. And then in December, we were able to finally place our order. So now moving into spring, just kind of a review of what's happened during this term is that we got our material delivered in late January, and then we started the fabrication process shortly after. So in February to early April is when we were fabricating, and we are still actually just wrapping up assembly. So really that just consisted of cutting down our large stock that we got delivered, which really large material pieces, typically up to 20-foot length. So we got that cut into shorter pieces, and then we got cut into actual rough dimensions. So then we could start fabrication. And then we started drilling holes, doing assembly, all sorts of stuff. And now as we get into April, we're now going to get into testing, doing our first round of testing, move into our refinement, do it like an assessment stage, look at it, make sure it meets our requirements that we set out there, and then hopefully try to do a video demonstration for our senior capstone and for Scholars Day.
Alrighty, this is Ethan here. I'm gonna go over the budget. So originally we had that full size, full budget, lots of sponsors version, 53-foot trailer, and then we scaled it down to kind of a Mark II, which still had the same height as the 53-foot trailer, still had the same capability. It just had less capacity for hay bales, so saving on steel a little bit. And then from there we went to a small scale, small budget for the boat trailer, and then something kind of cool happened. We got more sponsor money than we thought we were, so we kind of moved up to the medium budget, small scale version we have now. Next slide, please, Taylor. So one thing that kicked up our budget a little bit, but not as much as we would have expected, is the FEA and CFD on our Mark III trailer. The results of that went on to our Mark IV. We're currently on the Mark V, which is just a few little supplier changes that we made to the Mark IV. We just ran some structural analysis and some vibration stuff. Our biggest failure points were on the offset, which is what the trailer, it's a piece that the whole weight of the trailer goes on between the tractor or truck and the trailer. And there's just a few pieces that were just a little too thin, so we just within our supplier's website we just upgraded up to the next size, and that was enough, um, with including a factor of safety. And then we also had a few reinforcements where we just went up to bigger shaft sizes or bigger bolts here and there, just in case something went wrong, and it was only a few more. It was only a few more dollars for maybe a 100% increase in strength in a few places. Next slide, please, Taylor. So thankfully, our sponsor, John Scotto, had a lot of stuff on hand for us we could use, like the trailer, the boat trailer that is, and a lot of experience with hydraulics and the tools required for those. So we also had some tools in the shop we could use, but not everything in the shop we could use. So we had to get all that together. Um, Later in the design, we switched from a electrical system to a hydraulic system. That saved some money here and increased some costs there, and we think it came out about even. It just simplified the design and made it a little bit more applicable to our function of being a farm trailer. And then we also got a lot of donations that we didn't, in some cases, we didn't expect. So those being Pepe Machinery, Olympic Iron Works. That hose guy was a local guy who came in at the last minute and really helped us out. And then Scotto. Next slide, please.
Prototype and progress. So in this above images, we're gonna have we have the parts acquired, painting, the frame welding, the gravity roller welding, along with the axle holes drilled. Also, in the above image on the top left, we also had to hone out all the holes for the wheels. And these images show Taylor B welding all the gravity rollers on. Next slide, please. So the next steps, mounting the hydraulic motor, mounting the hydraulic cylinder, setting the sprockets and chain buffers, installing the trailer offset, and testing the prototype. Next slide, please. The end. Thank you for watching. Really appreciate your time. Take care.